Okay, now the problem we are going to consider is this. A body is projected at t equals to 0 with a velocity of 10 meter per second at an angle of 60 degree with the horizontal. What is the angle? 60 degree with the horizontal. The radius of curvature of its trajectory at t equal to 1 second is r. So r is the radius of curvature. Neglecting air resistance, okay, and taking acceleration due to gravity g as 10 meter per second squared, the value of r is option A 10.3 meter, option B 2.8 meter, option C 5.1 meter, option D 2.5 meter. So we see how to do this problem. First of all, we draw this diagram, and moreover this question was asked in 11th Jan 2019 JEE mains shift 1. Okay, first we draw this diagram. So this is the projectile motion, and this is the particle's position after time t equal to 1 second. Okay, the projectile was projected from here and it travels like this. It has come here after a time 1 second. T equal to 0 is the initial instant where the projectile is projected. After t equal to 1 second, the projectile has come here. Our aim is to find radius of curvature to this path at this point. Okay, this is velocity of projection. You can resolve this into two components. Of course, it's given the velocity of projection 10 meter per second. Resolving this into two components. This angle is angle of projection 60 degree. This is horizontal component of the velocity, that is initial velocity. Because this is velocity of projection, this is horizontal component of velocity, angle of projection 60 degrees. So we can find ux and uy. So ux is equal to u cos theta. This word u, this letter u indicates initial instance. So ux means x component initially, which is u cos theta. U is 10, 10 cos 60. So cos 60 is half, we know. So this horizontal component here is 5 meter per second. Okay. Similarly, we can find initial vertical component uy, which is this value, which is u sin theta. So we know that sin 60 is root 3 by 2. Sin 60 degree root 3 by 2. Okay, yes. So what is uy we got? We got uy as 5 into root 3 meter per second. So we know initial vertical component, we know initial horizontal component, and the angle of projection 60 degrees. So we will come to this position of the particle after time t equal to 1 second. This is P, t equal to 1 second. And the sign convention we will follow is upward positive, downward negative. Positive, negative. Okay. You can even take the other way around, that does not matter. Accordingly, you will have to proceed. That's the only thing. Okay. Now coming to this point P, this is the net velocity V. That is the velocity at P means only that net velocity, which can be resolved into horizontal and vertical component here, but the horizontal component here will be same as this horizontal component. Okay, that is the horizontal component of velocity at P. Vertical component of velocity at P. It will be down when time t equal to 1 second. Suppose if it is this side, the vertical component will be upward. In that case, it will be positive. So Vx is 5 meter per second, that is here. V V is final velocity, no, Vx 5 meter per second, which will be same as the velocity here. Okay, then what is Vy? Use equation of motion for finding Vy. V equal to u plus at formula. So Vy is, V is u plus at, so Vy is uy plus at, uy is 5 root 3, this one, sorry, V equal to u plus at, so Vy is equal to uy plus at, uy is 5 root 3, a equal to g, which is 10, it is given here, but it is taken negative, minus g we have to write. Why? Because it's in the downward direction. You see this. T is 1 second. So 10 into t is there. 10 into t, 10 into 1 is 10. So simply written 5 root 3 minus 10. If you evaluate 5 root 3 minus 10, you will get negative value. That is justified because this is acting vertically down for the time t equal to 1 second. Okay. Vy can also be positive depending on where the particle or the projectile is. Okay, next one. Obviously, this velocity v, use parallelogram law vectors. Angle between the two components being 90 degree, v equal to root of vx square plus vy square. Substituting for vx and vy. So vx square is there, no, vx square. Vx is 5, so 5 square is 25. Vy is 5 root 3 minus 10, so the whole square is there, 5 root 3 minus 10, the whole square, right? When you simplify this, you can use a minus b whole square formula, right? Okay. So 25. Is it clear? So 5 root 3, a minus b whole square is a square minus 2ab plus b square. A square, 5 root 3 square will be 75 minus 2 into 5 root 3 into 10. So minus 100 root 3 minus 10 the whole square. That is square of minus 10, which is 100. So now you simplify. 100 here, 75, 25. So 100 and 100. So root of 200 minus 100 root 3. Right? Here you can take 100 outside. When you take 100 outside, because here you have 200, here you have 100. When you take 100 outside, it becomes 10. So square root of 2 minus root 3 is the velocity at p. So when you evaluate this, you will get 5.18 meter per second. It's only the magnitude of the velocity at p, right? So r is equal to, that's what we want, r is equal to v cube by gu cos theta. This one we have already proved in one of our earlier videos. You can refer to it. So r is equal to v cube by gu cos theta. V 5.18, g 10, u again 10, cos theta, theta is 60. So substitute the values. Okay, so it is simply 5.18 cube by 5 into 10, which is 50. When you simplify this, you get 2.8 meter. So the radius of curvature of the projectile's path after 1 second from the instant the projectile was projected, that means when the projectile is at p, the path has a radius of curvature 2.8 meter. So the correct answer is 2.8 meters. Okay, thank you.